Alright guys, last time we started taking a look at graphing exponential and logarithmic functions, and we had this wonderful little parent graph here. But last class we did it where we didn't really have a value for a, we didn't really have a value for h, and we didn't really have a value for k. So obviously it seems like that's the next thing that we should be going through and doing. So let's take a look at a few more examples of how we can graph exponential functions, but this time with those transformations. So the first one that we're going to look at here is f of x equals 5 raised to the x minus 2 minus 3. So we can see here that there's going to be two transformations. There's going to be a horizontal shift of 2 units and a vertical shift of 3 units. Okay, what direction are those going to go in? Well, this is x minus 2. H is always a liar, so it's going to move 2 units to the right in the positive direction. And this value of minus 3 here is going to shift it down by 3 units, okay? So we're going to graph this the same way that we graphed all the other ones. We're really going to try and go and make a nice, pretty t-chart. But I'm going to give you guys a piece of advice, okay? Something that can be really helpful. When you're trying to decide where you want to center your t-chart, always take a look at your exponent, okay? We want to take a look at that exponent and set it equal to 0. So I'm going to take that exponent of x minus 2 and set it equal to 0. That is going to be a mathematically true statement when x equals 2. So I want to center my t-chart at 2, okay? So that means 2 is kind of in the middle, and I'm going to put 2 values that are less than 2, like 1 and 0, and 2 values that are greater than 2, like 3 and 4. So that's going to give me a decent number of points to go and be able to sketch a graph of this particular function. So let's go through and plug it in and explain why it is that we want to go and set our exponent equal to 0 and center our t-chart that way. So if we look here and I use direct substitution, I have 5 and I'm raising that to the 2 minus 2 and then take 3 away from that. Well, following order of operations, I'm going to go and do what's in the exponents first, right? So 2 minus 2 is 0. Well, that's 5 to the 0. Well, anything raised to the 0 is 1, and 1 minus 3 is negative 2. So that's the reason why you want to go and center your t-chart at whatever value would make that exponent 0, because we really want to have a 0 exponent there, okay? So doing the other ones, if I plugged in 1, I'd have 5 to the 1 minus 2. That's 5 to the negative 1. That is 1/5. 1/5 minus 3 is going to give me, what, negative 2.8? If I plugged in 0, I have 5 to the 0 minus 2. So that's 5 to the negative 2, which is 1/25, or 0.04. And 0.04 minus 3 is negative 2.96, okay? So you can see that these numbers are getting closer and closer to some value. Probably that one. Yeah. All right. So if I plug in a positive 3, so we get 5 to the 3 minus 2 minus 3. Well, that's 5 to the first, which is 5. And 5 minus 3 is a positive 2. And then to round things out, we've got 5 raised to the 4 minus 2. Take 3 away from that. Well, 4 minus 2 is 2. 5 squared is 25. 25 minus 3, 22. Okay, so I'm not going to fit on the graph, but it is going to tell me what direction to go. So let's go plot those points. We've got the point 0, negative 2.96. So 0 and 1, negative 1, negative 2, negative 3, but a smidge higher. So we'll mark it right there. 1, negative 2.8, so just a little bit higher than the one that came before it. 2 and negative 2, so now we're starting to head up. 3 and positive 2. And then I would be graphing 4 and 22, but that's probably not going to fit, okay? Then I'm going to go look at this value of negative 3 and realize that that is my horizontal asymptote, which makes sense because I'm getting closer and closer to it. So let's go ahead and draw my nice little dashed line here for my horizontal asymptote. And then I can play a super fun game called Connect the Dots. So we're going to go here, and then we're going to kind of turn up, and we're going to get really, really steep, okay? So in general, that's kind of the shape it's going to look. Is that the world's greatest graph? No, I'm a math teacher, not an artist. So if we look at this really amazing superdy-duperdy picture, we can go and identify all of the characteristics of this exponential function. Please remember, we're not on logs yet, haven't gotten there. Skip it for now. We'll come back to it in a little bit. So the domain of this function is all real numbers because, well, that's what the domain for pretty much every exponential function is. The range, well, the smallest value is this -3, and it goes all the way up to where y is infinity. So you guessed it, -3 to infinity. The intercept, well, in that case, it's going to be the y-intercept. We can't quite figure out how to get the x-intercept yet. We will later, so this is just going to be the y-intercept. So we're going to go ahead and say that when x is 0, y is -2.96. So 0, -2.96. My asymptote is the horizontal line, y equals -3. If you do not put the y equals, you did not tell me the asymptote. And then looking at my base is 5. 5 is greater than 1, so this is going to be exponential growth. So we could alternatively say that it is increasing across its entire domain. Okay, so similar to what we did during our last class period, the only difference is our t-chart is not automatically going to go -2, -1, 0, +1, +2. We got to kind of play around with the 5 numbers that we're going to go through and pick. And we do that by taking the exponent and setting it equal to 0. And then this one also has a horizontal asymptote that's not located at 0. So it's just kind of a shift down of 3 units. Easy peasy, lemon squeezy. Let's go take a look at the next one, okay? So this one is f of x equals -1/5 raised to the x plus 2. I want you guys to think about this. When you see a negative in the front here, okay? Think of it as -1 times a base of 1/5 raised to the x plus 2. It's going to make doing the transformations a little bit easier because I can see here that it has not been shifted left or right horizontally. It has a horizontal asymptote at 2, but it's also been reflected probably over that horizontal asymptote because you've got a negative sign here, okay? So looking at this one, let's do what we did last time. Let's take a look at our exponent, which in this case is just x, and we're going to use that as a way to figure out what our t-chart should look like. So we go and make ourselves a little t-chart. I know you guys love t-charts almost as much as I do. We're going to want to center this particular function at 0, or where the exponent will be 0, which in this case is 0. So we can go 0, -1, -2, a +1, and a +2. So we're kind of back to our standard 5, but that's just because we don't have any horizontal transformations going on here. Then I'm just going to go and plug stuff in, okay? So first I have -1 times 1/5 raised to the -2 plus 2, okay? Doing some arithmetic, follow your order of operations. 1/5 to the -2 is really the same thing as 5 squared. Well, that's 25. 25 times -1 is -25. -25 plus 2 is a -23. Next up, we have -1 times 1/5 to the -1 plus 2. Well, 1/5 to the -1 is really 5 to the first. 5 to the first is 5. 5 times -1 is -5. -5 plus 2 is, well, -3. Okay. If I plug in 0, that should keep things easy. -1 times 1/5 to the 0 plus 2. 1/5 to the 0 is 1. -1 times 1 is -1, plus 2 is a +1. If I plug in a 1 here, -1 times 1/5 to the first, plus 2. 1/5 to the first is 1/5. -1 times 1/5 is -1/5, which is really like 0.2. And negative 0.2 plus 2 is 1.8. Okay, and then finally we've got negative 1 times 1/5 squared plus 2. 1/5 squared is 1/25, or 0.04. So it's negative 0.04 plus 2 is 1.96. Okay, so I realize I'm kind of writing all over the graph here, but that's what I got room for. So we're just going to enjoy it. So let's go through and plot those points. So I had a negative 2 and negative 23. Well, that's not going to fit on this graph. Negative 1, negative 3. So negative 1 and negative 1, negative 2, negative 3. Bam, bam. 0 and 1. Well, 0 and 1. Bam, bam. 1 and 1.8. So that's less than 2. And then we've got 2 and 1.96. Okay. I can go take a look at my value of k over here, and I know that that is going to be where my horizontal asymptote is. So I'm going to have a horizontal asymptote where y is equal to 2. So you can see this just looks like a regular exponential function, only it's like upside down and stuff. So if I play my super fun game of connect the dots and just kind of go through and do it like this, okay, not a work of art, but I'll take it, okay? So wish that had been a little smoother, but it's all good, it works, okay? So here's this graph for this exponential function. It's pretty obvious what that negative 1 does, okay? It just reflects it over your horizontal asymptote, okay? So a negative value of a reflects the function over the horizontal asymptote, all right? So looking at this, let's get some characteristics from it. What's its domain? Well, it's still all real numbers because there aren't any values that I'm not mathematically able to plug into this function. I can plug in negatives, I can plug in positives, I can do it all. The range, though, is going to be a little bit different because you see how it starts way down here at negative infinity, but it can't ever be greater than 2. So negative infinity. And then it goes all the way up to, but does not include, 2. The intercept, okay, again, I'm going to say for right now, it's the y-intercept. That's going to be the point 0, 1. My asymptote is the horizontal line, y equals 2. And the million-dollar question, is this growth or decay? All right, so here's the kicker. The base is 1/5. So technically, this is decay. All right, we're not looking at the graph. We're saying technically it's exponential decay, but it has been reflected. Okay, we have to call it reflected decay. We cannot call it growth. And here's the reason why. By rule, exponential growth keeps getting bigger. This function can't get bigger than 2. 2 is not a very big number. So we can't say that it is exponentially growing, okay? We can say that it is increasing over its interval, but we cannot call it exponential growth, okay? It is reflected decay, all right? So that's really all we have for you today. We've got our graphing exponential functions worksheet 2 that has a lot of transformations. Having the one that you guys did during our last period, our last class together, would probably be helpful because the bases for all 6 of the functions are exactly the same. You're just making certain transformations on them, okay? But what we need you guys to do is take a look at each one of the functions, kind of identify, whether you write it out or not, the transformations, make your t-chart where it's appropriately centered. Sometimes that'll be at 0, sometimes that'll be at 2, sometimes that'll be at -5. It doesn't really matter. You just use the exponents to figure out where you should center that t-chart. Once that's been done, you can create your t-chart, plot your 4 to 5 points, look at the graph, identify the characteristics, and put a fork in it because you're done. So get to work, ask questions if you have them.